So last week we started to talk about, as we talk about the carrier concentration, we were focusing on the current, but to know the current, we should talk about the carrier concentration and the velocity of each carrier. So as we talk about the velocity, we move on to the part of we are talking that drift velocity, and drift velocity we're talking about the current part. So the current part is especially divided into two parts, which is related with the drift velocity, and the other part is the diffusion velocity. So as last week I was filming this for the drift velocity and drift current and diffusion currents, and I'm going to talk about the next part of it. So we were learning about the next part is that the combination and the recombination and the generation, and we talk about this kind of term when we are learning about the energy band. So as we talk about the energy band, the definition of the valence band and the conduction band, as we talk about in the 0 Kelvin, the conduction band is not any occupied with the electron, and the valence band is fully occupied with the electron, as we learned. So the combination is related. So generation is, we can say, in a pair like electron and holes, and the meaning of the recombination is that if there is no energy in it, and the electron is excited by the photon and a certain energy, which is, it can be thermal energy or whatever it is, and if that energy get it, electron get energy, it's excited, so it's move on to the conduction band, and the conduction band then they can be made in a hole and electron and hole pair. But the problem is that it's not a problem, but the recombination can be happen because if there is no energy, the electrons just come down to the valence band, which is just, we call it recombination. And as we talk about the recombination and generation, it can increase the amount of the carrier with electron and the hole. And also the problem is that we talk about the continuous equation, and continuous equation the reason why we're talking is that by recombination or generation, the electron or hole can be increased or decreased, so the amount of carrier can be different in a certain part, so the diffusion current can be made. And if we want to know about the different part, we are focusing on the minor carrier, because in n-type there is a more electron and there's less hole. So if we see the whole part, we can see the big differences. And as we think of the same part in the p-type, there is a big amount of hole and there is a small amount of electrons, so we can say we can focus on the part of the electron which is the minor carrier that we call. So about the recombination and generation, we were talking about that, and as we move on, we were learning about the equilibrium. So it's like the Fermi level was just same, but if there is a certain carrier for the electron and the hole, and if we generate or with the generation, the carrier concentration can be changed. So the electron and the current can be changed. And next we talk about the graded doping, and graded doping is that if we learned about before, we were learning we learned about the doping, but doping was the problem is that we were saying that doping is all same in the same part, like all part, but the amount of doping for each part can be changed. So it's making diffusion current as the polarity of certain, the carrier, there's a certain carrier that makes graded doping, and that because of that there's making a diffusion current, and diffusion current, after that we are making a certain electric field and the conduction band, and so because of that the Fermi level can be changed. And we're talking about that, so maybe after that we are going to learn about the p-n junction, and p-n junction is the really short form that the equilibrium Fermi level that is related. So next week maybe I'm going to talk about the p-n junction part. Thank you.